this example, consider the sequence. It's given by 2 over n squared. N goes from 1 to infinity. And I want to know, is this a bounded sequence? Okay. Is this sequence bounded? So it might help if you start, like when we were doing increasing and decreasing, I wrote out terms in my sequence. It might help if you write out some of the terms to see what's happening here. So what do I get for A1? 2, 2 over 1, which is 2. A2, 1/2. A3, 2 over 9. And we're not asking about increasing or decreasing anymore. We're asking about bounded, right? It looks like I have an upper bound, right, from my numbers. What would you guess the upper bound is? 2. That's the largest value that I'm getting, because after that, what's happening is my denominators are getting larger, which gives me a smaller number, right? So in turn, we can say that A sub n is less than or equal to 2, because we know A sub n, the formula, it's 2 over n squared, and n equals 1 is the largest value I get. Yes?
So if your first number is your biggest value, then you have a upper bound.
The problem is we only wrote out some of the numbers, so we don't know it's the biggest value. The reason I know it's the biggest value is because of the formula. I'm looking at 2 over n squared. And what happens is n gets larger, my denominator gets bigger, so I'm getting smaller values. So it's really based on the formula that I knew the 2 is the upper bound. Okay. So this tells us we're bounded what? Above. This tells me that my sequence is bounded above.
Wouldn't it be bound to 2 and 0?
Yeah, you just told me it's bounded by 0 as well, right? Because how did you know that it was bounded by 0?
It's always going to be positive.
It's always positive. So I know that this 2 over n squared, it's always positive, so it's actually strictly greater than 0. And this tells me that my sequence is bounded below as well. So whenever a sequence is both bounded above and bounded below, then we know we call it a bounded sequence. So 2 over n squared is bounded. Okay. Any questions about that particular one? All right, let's do one more together. So, is the sequence -1 to the n bounded? So it'll do the flip thing, right? Okay, which tells me it's definitely not increasing or decreasing, right? If I was talking about that flip-flopping back and forth, but bounded, right? Let's think about the graph for a second. We plotted this last time. 1, it's -1. 2, it's +1. 3, it's negative. 4, it's positive. Right? It's doing this flip-flopping thing you told me. You can think about bounded also in like a visual context. Bounded just means your points can't go too high. There's a cutoff, and they all stay below, right?
So it is bounded.
So it is bounded. It's bounded between 1 and negative 1, right? Exactly. This sequence, negative 1 to the n, it's always between negative 1 and 1. It's one of those two values. So this tells me that this is a bounded sequence. It is a bounded sequence. Okay, so you can think visually if you want, if you plot your sequence as these points, bounded above means it doesn't go beyond a certain point above, and the same thing for bounded below. There's a cutoff on the bottom where it doesn't go below that value. Okay, all right, so now it's your turn to try. So I'm going to ask, is the sequence n over n plus 1 bounded? So take a couple minutes and see if you can figure this out. If you have no idea, start by writing out some of the numbers in this sequence and see what you get, okay? So we're going to take a minute or two to do this. If you're finished, you can ask someone next to you if they got what you got. Talk about your answer. Okay, so let's come together. What do we think? Is it bounded?
never reach one.
It'll never reach 1, right? It's always, so you're telling me that it's bounded above, right? This is always going to be less than 1. That's because the denominator is bigger than the numerator. So I'm getting a number smaller than 1 when I divide. This tells me it's bounded above. What else do I need to know?
It's bounded below.
Bounded below. What's it bounded?
Greater than or equal to 4.5.
It's greater than or equal to 1/2. I'll give you that. The easier bound for you to get is that this is strictly bigger than 0. It's positive. But I think you're right. I'm pretty sure that this is a decreasing sequence. So you could also have 1/2 here instead if you wanted that as well.
So we need to be careful about that, right?
I mean, you have to make sure that it's true what you're saying, but there's more than one bound. If I say, like here, I said this n over n plus 1, it's less than 1, so it's also going to be less than 2, right? Or 3. So an upper bound and a lower bound is not necessarily unique. So that's one thing to take into consideration, is that you have options. You just want to say something that is true.
So like, we know for sure that since it looks like it's not going below 1/2, we can just say it's not gonna go.
I mean, we would still need to show this. That's why I said I would go with the easier bound. I know for sure that this is bigger than 0. So I know that that inequality is true. If you want to show that it's, so you're also telling me that this inequality should be true, right? And so if it's true, we better double check it. So if I cross multiply, because all these numbers are positive, I can cross multiply and it won't flip my fraction at all.
Equal to side also.
Yep, equal to. Thank you. Yep. So if I get all my terms on one side, I subtract it in and I subtract, well, I'm going to leave the 1 over there actually. I'm just going to subtract it in. Is this inequality true? Is n greater than or equal to 1? Is that true? Oh, sorry. Is n greater than or equal to 1?
It's only greater than.
It's greater than or equal to, it's okay, yeah. N equals 1 to infinity. So even if it was greater than, it's okay because it still would be true, right? So because this inequality, because this is true, what it tells me is that this original one is also true. So when you're making these statements about upper and lower bounds, you actually have to double check if they're true. Listing out the numbers is only going to tell you that it's true for the first few values, not in general. Okay? So kind of similar to what we did with increasing and decreasing when we were comparing an plus 1 to an and we did inequalities, same kind of idea here.